simplify each expression below using properties of exponents. So for a, we have 9xy to the negative 2. So the important thing to remember here is that every part of the problem has its own exponent. 9 has an exponent of 1, and x has an exponent of 1 also. That negative 2 only affects the y. So we want to end up with a problem that has all positive exponents, so we're going to move the base that has a negative exponent, which is just the y, over the fraction. We get 9x over y to the 2. b. Here we have 9xy to the negative 2. And this is just to kind of contrast a. Here, notice how the x is included in parentheses. That's how it would be written and have to be written if the negative 2 were to apply to the x. So, since it is in parentheses, the negative 2 does apply to the x. So, in order to make the negative exponent positive, we move the base, which is the whole entire xy, over the fraction. The 9 still has the power of 1 because it's still outside parentheses. So in this problem, 9 is going to be over x y squared. Now we could take that maybe a step further and write that as 9 over x to the second y to the second. C. Here we have 11x, that's to the negative 1, and 3x, that's to the negative 2. Each of these respective pieces is to a negative exponent, so both of them have to move. So, when we move the 11x to the minus 1, it's going to become 11x to the positive 1 on the other side of the fraction. 3x to the negative 2, that moves to the other side of the fraction as well. That's 3x to the positive 2. Now we should probably finish this off by simplifying a bit. Because of the parentheses, the exponents apply to each. 3 to the second's 9. But that doesn't burn the exponent. It still applies to the 2 as well. So it's 9x to the second. Over 11x to the 1, well, that's just 11x.